Hello, my name is Joel Oskarsson. I'm a postdoc fellow at ETH Zurich, and I'm happy to give you a short introduction to this tool, AI Earth Model Explorer. So this is a tool that's been developed by a group of students and researchers at ETH Zurich in order to assist the developers and users of AI weather models. And we specifically developed this with graph-based models in mind. And we hope that this will be a useful asset for people who want to both explore and understand these models, but also to use during model development processes. So you can see already now the tool on the screen. And as you are using this, you will find all of these small guides that actually guide you through all of the details within the tool. But this video serves as a kind of high-level overview first now. So there's three different views in AI Earth Model Explorer. So there's the Explore view, the Inspect view, and the Explain view. The Explore view, where we can start, that's really where you can explore the different graphs used in graph-based weather models and understand the different connections that they have. So generally, we will have a upload functionality in the tool where you can upload different graphs from models you're developing, but we will also preload this system with a few graphs for you to explore. So right now, we're looking at a multi-scale graph in the style of the GraphCast model, but here designed for 1.5 degree resolution grid rather than a 0.25 degree. So to the left here, you can see the different model components that you can show or hide. So right now, only the actual graph is showing, but then we can show the actual grid points instead, or we can show the different edges, these encoding grid to mesh edges. If I zoom in here, or similarly, the decoding edges that map from the graph back to the grid. So here one can look at different components of the graph and also explore what the coordinates of different nodes are, for example. We will also include a hierarchical graph in here. So the difference between this one is that here the actual different length scales within the graph, the different resolutions are separate. So you could actually start looking at just the original icosahedron and then choose to view more and more of the different parts of the graph. Then we have the inspect mode. So if I choose just the graph here, the inspect mode is really made to be able to look even further into the different properties of the graph. So we get this menu to the right here, where we can choose to filter on different graph properties. In particular, we might be interested in looking at something like the lengths of different edges, and then we can slide this slider here to actually visualize different, the longest edges in the graph, for example, or conversely, if we wanted to just look at the shortest ones, we can do something like this as well. So keep in mind that this is very much a research prototype, so that this might not be the most optimized system currently, but it works fairly well to actually explore these things, and especially for your own understanding. But we are very happy to get any feedback on how you find using it. So the final setting here is the explain part of the tool. And this is a little bit separate and a little bit more experimental than the previous ones. So here we're not looking at the graphs specifically, but we are actually taking graph-based models and we're considering the input to output mapping and applying explainable AI techniques to this. So we preloaded the tool here with a GraphCast-like model. So this is a GNN in the style of GraphCast, but it operates at this coarser 1.5 degree resolution. And what we see in front of us here is a map of the error from the model predictions. So specifically, this is the 1-step 6-hour prediction for the date that is selected down here. And then we can choose something like, let's say we're interested in the 2-meter temperature prediction, for example. Now we see the error for this. And if we then choose, let's say we choose some area that has a pretty high error here, then this brings up this attribution view where we're actually explaining the prediction of this error. So if we zoom in here, then we can see is that now we're actually explaining the prediction for 2-meter temperature in this grid cell based on the input of 2-meter temperature at 12 hours back in time and 6 hours back in time. Because as you might know, these models take typically as input, not just the previous state, but actually 2 time steps back into the future. But we might not be interested in just the 2-meter temperature. We can see that, okay, clearly this affects the temperature in the vicinity, clearly affects the temperature, and this is what the model uses. But we might look at something else, how winds, for example, at specific levels here actually is used by the model in order to make the prediction for 2-meter temperature here. So these are fairly crude explainability techniques. So they are in some ways telling us that the model is using these inputs in some way, but we don't get a lot of insights into exactly how this mapping looks like. And there's also 2 different explainability methods implemented here that you can swap in between. The default one is a very quick one to do the computations for, but we have one that is a little bit more refined, but then also actually takes a bit of time that you can switch to here. So there's lots of things to explore here, and hopefully this gives at least a bit of an overview and a starting point, but then also do check out all of the different tutorials that are actually present within the tool itself. We hope that this will be useful for your learning and for being able to understand these models. And as you maybe start developing such models yourself, it could also be useful as a tool during that process. We are very happy to hear any feedback and how you could envision yourself using this in your own workflows and within your organizations in the future. Thanks.